Hello and welcome to the session. In this session, we are going to discuss the following question, and the question says that solve the following inequality: 3x square minus 5 is less than minus 2x. Display the solution on the number line. Let us start with the solution. We have to solve the inequality 3x square minus 5 is strictly less than minus 2x. We will follow some steps to solve the inequality. Our first step is to set one side of the inequality equal to 0. For this, we add 2x to both sides. We get 3x square minus 5 plus 2x is strictly less than minus 2x plus 2x. This implies 3x square plus 2x minus 5 is strictly less than 0. Our next step is to factorize the given inequality. We have the quadratic 3x square plus 2x minus 5 strictly less than 0. Let us factorize 3x square plus 2x minus 5. This will be equal to 3x square minus 3x plus 5x minus 5, which is equal to 3x into x minus 1 plus 5 into x minus 1, which is equal to 3x plus 5 into x minus 1. So we can write 3x square plus 2x minus 5 strictly less than 0 as 3x plus 5 into x minus 1 strictly less than 0. Now our next step is to find the critical points. For this, we equate each linear factor equal to 0. That is, we get 3x plus 5 equal to 0 and x minus 1 equal to 0. On solving these linear factors for x, we get x is equal to minus 5 by 3 and 1. So, the two critical points are minus 5 by 3 and 1. Our next step is to make a number line and plot the critical points on the number line. Let us make a number line. This is minus 5 by 3 and this is number 1. Since minus 5 by 3 and 1 both do not satisfy the quadratic inequality because of the strictly less than symbol, so we will draw hollow circles on these points, which indicates that these points are not included in the solution set. Now our next step is to determine the region based on these critical points. To determine the region based on these critical points, we draw vertical lines on these points. Now we see that the number line is divided into three regions. Region 1 with values less than minus 5 by 3, that is open interval minus infinity minus 5 by 3. Region 2 with values lying between minus 5 by 3 and 1, that is open interval minus 5 by 3 1, and region 3 with values greater than 1, that is open interval 1 infinity. Next step is to check the sign of the inequality written in the factored form in step 2 to determine which region belongs to the solution set. In step 2, we obtained the inequality in factored form, that is 3x plus 5 into x minus 1 is strictly less than 0. Now we check the sign of LHS of the inequality for each region by choosing any point in the region. Region 1 is open interval minus infinity minus 5 by 3. So let us choose x equal to minus 2, which lies in this interval. Put x is equal to minus 2 in 3x plus 5 into x minus 1 and check its sign. Sign of 3x plus 5 is negative when we put x equal to minus 2 in this factor. Sign of x minus 1 is negative when we put x minus 2 in this factor. So, sign of the product is equal to minus into minus, which is equal to plus. So we write a plus sign on the number line for this region. The next region, that is region 2, is open interval minus 5 by 3, 1. Let us choose x equal to 0 in this region. Put x equal to 0 in 3x plus 5 into x minus 1 and check its sign. Sign of 3x plus 5 is positive when we put x equal to 0 in this factor, and the sign of x minus 1 is negative when we put x equal to 0 in this factor. So, sign of the product 3x plus 5 into x minus 1 is plus into minus equal to minus. So we write a negative sign on the number line for this region. The third region, that is region 3, is open interval 1 infinity. Let us choose x equal to 2 in this region. Put x equal to 2 in 3x plus 5 into x minus 1 and check its sign. Sign of 3x plus 5 is positive when we put x equal to 2 in this factor. Sign of x minus 1 is also positive when we put x equal to 2 in this factor. So, the sign of the product 3x plus 5 into x minus 1 is plus into plus, which is equal to plus. So we write a positive sign for this region on the number line. Our next step is to write the solution set in interval notation and graph the solution on the number line. We have the inequality 3x plus 5 into x minus 1 is strictly less than 0. Here we have a strictly less than symbol. So we choose those regions which give values less than 0. That is negative values. See, in the sign chart, we have one region showing negative sign, which means this region will satisfy the given inequality and will form the solution set. This region is region 2. Also, the critical points are not included in this region because we have a strictly less than inequality. So the solution set in interval notation is given by open interval minus 5 by 3, 1. Now we graph the solution on the number line. For this, we darken the number line from minus 5 by 3 to 1 with hollow circles at minus 5 by 3 and 1. This is the required graph of the solution set. This completes our session. Hope you enjoyed the session.